Good morning. Please start by logging into Clever. All right, so let's think about your future. For your warm up today, where do you see yourself in 10 years? Thanks for sharing. So, welcome to week 9. This is lesson 16. We are approaching the end of NTI 2.0 as we will transition either to a new version of virtual learning or to our hybrid in person learning. This week, we're talking about what makes different materials different. So my reminders for you are kind of the same as always. I did a bunch of grading yesterday on Google Classroom. I haven't fully updated it on Infinite Campus, so just give me a second there. But make sure that you're checking Google Classroom to see what assignments were graded, what was returned to you, what comments were left, etc. If you didn't get a chance to do something, or if I returned something to you because it wasn't done how I needed it to, remember you can always do that whenever you want to and whenever works for you. Remember with the Edpuzzles, anything with a number in front is required. And if you come to the live lessons, you don't have to do the Edpuzzle recorded version. So if you're watching this right now, it was because you weren't in the Edpuzzle or in the live lesson that we had earlier. Remember to use your resources to meet our classroom expectations that we've become experts at for our virtual class. But as we move to in-person learning, we need to start to train our mind to what it means to be safe, responsible, respectful, prepared, and here in our in-person classrooms. If you have questions about what the return to school is going to look like, I ask you to check out a couple of the resources that I have made for you. One is a tab on my Google site, which you can find. Again, it's right there underneath home. It has links to all kinds of things. Those same links are also organized in a return to school material on Google Classroom. It's a little cuter and more organized over on the site, but it's also all of the links are here for you. So if you have questions about it, don't hesitate to check that out, as well as don't be afraid to put a question in the return to school form question form. If you have other questions, or if your parents want to kind of see what's going on, or if you are new to Western and want to see what the school building is going to look like, you can come tomorrow, actually Wednesday the 17th from 6:30 to 7 for a walkthrough where you can see what some of the procedures are, see how things are going to be set up, see where your classrooms are, get your schedule, talk to an adult, get some resources, whatever you might need. Because again, even if you're not new to Western, the Western that you remember is very, very different. Things will have changed pretty dramatically because we are putting a lot of procedures and safety protocols in place to make sure that we're all in a good place and nobody gets sick. So another thing to remember is that if this all sounds like too much and you're like, this is already like stressing me out, you can always remain virtual. That is changing slightly, but it will involve you staying at home to do your work and getting live time with me a couple of times a week, okay? So just remember that you got options, do what's best for you, and make sure that you talk it through with your parents. So for this week, though, this is our last normal week of NTI because next week will be asynchronous. Don't worry, I'll walk you through that at the end of this week and then with your preview next week. But this week, we're going to talk about what makes materials different from each other. Today, you are going to have one assignment. You're going to have a material science Cornell notes. There'll be 2 assignments that go with our second lesson of the week. You should be here before you give the Cornell notes a shot because we are going to go over some things that will make them that much easier for you. And as this week and next week and over spring break and whatever, as we head towards the end of the school year, because it is closer than we think, remember you can do makeup work whenever. So just do your best to get caught up. I will get to it and I will grade it and I will update it at a time that works for me. But you put in the effort and I will make sure that you're rewarded for it. So thank you guys for being awesome. Let's do this. All right, our last lesson, I talked about material science being the study of materials. So the design, creation, production of new materials to be used for everyday purposes. And we started to brainstorm and think of some terminology and some descriptions and some properties that it's important for us to pay attention to when we're thinking about different materials and different objects. So let's start by brainstorming what are some of the desired qualities of, let's say, this chair. Okay? There's no right or wrong answers here, so don't freak out. But some things you might think about is that we want the cushion to be soft. We want it to be comfortable. We don't want it to be scratchy and hard. We want it to be flexible and resilient. We want the body of the chair to be sturdy and rigid and strong. We want the legs of the chair to be also sturdy and rigid and strong. So we're starting again thinking about what are some of these terms for these objects. All right, so what about the different parts of this object here, a toothbrush? What are some of the desired qualities and properties of a toothbrush? Cool. So you might have thought about the bristles. We need them to be flexible and kind of soft, but also still fairly sturdy. We don't want them to break off. We don't want them to like break apart all the time, but they need to be thin so that they can get inside of your teeth. The handle of your toothbrush needs to be pretty sturdy. It might want to have a little bit of a flex as it moves throughout your mouth. We don't want it to break. We don't want, so it needs to be pretty durable. And yeah, we have a lot of toothbrushes, so we want it to be something that lasts for a while, right? Okay, what about a plastic bag? What are some of the qualities we want of that? So we want it to be stretchy, we want it to be really light, we want it to be thin, we want it to be different colors or to have the ability to be different colors, right? And then what about this shoe? What do we want this shoe to be like? So we might say that we want the sole of the shoe, the very bottom, to be sturdy or to be water resistant. We want it to be really durable because, right, it's walking on stuff. We don't want it to break apart. We don't want it to fall apart. We want it to be able to last. The actual body of the shoe, you want it to be flexible, but you want it to be soft and comfortable. But you also want it to be able to hold a shape. You don't want it to just fall apart. And then the shoelaces, those need to be they need to be strong. They need to be linear, so in a nice straight line and straighten out. You want to be able to tie them and bend them. And so that's, if we think about it, it's like those three parts have way different properties. So why do different materials have different properties? Why do we think that is? The reality is that it is because each of these different materials have different structures, and those different structures result in those different properties. And so that's an important key tie in line of thinking that we want to keep in mind. So many of our commonly found materials are made of what are called polymers, which are long-chain molecules. They can be natural, they can be synthetic, they can be really, really long, they can be really short, but understanding what a polymer is one of the first things we need to make sure we get. So to kind of help us prime and understand what that means, take a look here at polyethylene, which is this image or this structure here, and ethene or ethylene right here. What are some similarities and differences that you notice? So many of you guys notice the similarity is that they have the same kind of basic structure, the one black ball with two white balls coming off, one black ball with two white balls coming off. The difference is that this ethylene, there's only two of them connected by two lines or two bonds. Over here with the polyethylene, we don't know how long it is. We know it's at least 6, but they're all connected by single bonds, and we can say that they kind of go in this zigzag shape. The ethylene is kind of straight across. That is super important. So when we talk about poly, there's many words. Poly is a kind of root word. It's a stem that can be found in many different words. So what do we think poly means by looking at some of these common poly words like polytheistic or polyamorous or polygamy or polyglot or polygon? What do we think poly is? Poly means many. So a polymer is a chain of many repeating units. Those units are called monomers. So what do we think mono means? That's another stem root word. If we know that what a monologue is, or a monorail, or a monocle, or if you're in a monogamous relationship, what do we think mono means? So monomers are these single units by themselves that when they go through a chemical process become a polymer, a long chain of those single units. So you can think about monomers as kind of like the beads on a necklace, and then the necklace, when those beads all come together and are strung together, that is the polymer. Okay? So once we understand that these are different forms of polymers, we want to think about what what is going on and why are these different and what does that mean and what are their properties and characteristics. So observe these four different polymer structures and just straight up tell me, what do you see is going on? What is different? What is the same? So you might notice that they have the same basic units, but each of them are different. B is long and straight. C is short. A has branches coming off that doesn't allow them to get very close, the two strings to get very close together. These are connected by literal, like almost crosswalks, right? So then we wonder, what do you think these differences mean about these molecules? There is no right or wrong answer, but what do you wonder or think that this might mean about the difference between A, B, C, and D polymers? Right. So you might start to think about, I wonder if this, because this is shorter, this means that it's not as strong or rigid. I wonder because this is long, if it is able, if it's more flexible, but it is stronger. I wonder if these connections here mean that it's going to be really, really strong and stiff. I wonder if this means the branches mean that maybe they don't get as close together, and so it's not as strong and it's very flexible. All right. That's the kind of stuff that we want to think about because a polymer's different properties are directly tied to the structure and shape of the polymer itself. And that's the work that you're going to be doing with your Cornell notes after this lesson. Our whole big picture is to kind of think in this term. Every object has materials that it is made out of. The materials that are chosen for that object are because of the properties of that material and what that object needs to do. The material itself has those properties because of the structure of the polymer. Our goal is to understand how these three pieces, these three elements come together and what they mean to each other. All right? So, like I said, you have one new assignment. It is a Cornell Notes assignment where you are going to be looking at the different structure of different polymers and working through that. You can do that in a couple ways. You can write them out. If you prefer to write them out, just include a picture. You can use the Cornell Notes template that I have attached as a document. You can just use the notes, the slides to copy the notes over into the Cornell Notes. Or if you're someone that really likes to interact in a Edpuzzle and kind of hear the lecture of it, you can also watch that Edpuzzle lecture. I think I said this earlier, but it's from the first time that I did it. So if you're like, this doesn't make sense, it's okay. You'll still get the Cornell notes and get the material science information that you need. All right. So I'm going to kind of finish up with this. If you need my help or have any questions about literally anything, please drop that now. All right, and we'll finish with this exit slip. How well did you like this lesson? Awesome, guys. I will see you next time. Have a great week.